Our final problem when dealing with delta x equals v sub I delta t plus 1/2 a delta t squared is to find delta t in seconds when we know the other three variables, where we know that delta x equals a certain displacement in meters, v sub I is the initial velocity in meters per second, and a, in this case, equals g, acceleration due to gravity, which is our negative 9.81 meters per second squared. This is a slightly different algebra problem because we now have a second order equation. That is, delta t is in the equation twice, once to the first power and once squared. To do that, we have to rely on some mathematics that we probably covered in Algebra 1 or Algebra 2 that deals with what we call a second order equation or a quadratic equation. We'll start by looking at how we could subtract delta x from both sides of our equation. Then we simply reorder our equation to look like this. All we did was realize that delta x minus delta x is 0 for the left-hand side and reorder things on the right-hand side so that 0 equals negative delta x plus v sub I delta t plus 1/2 a delta t squared. Now, all we have to do is reorder the terms in our equation so that we have 1/2 a delta t squared plus v sub I delta t minus delta x equals 0. If you look closely, these two equations are the same. We've simply flipped them and reordered the variables so that now we have 1/2 a times a squared term plus v sub I times a term to the first power minus delta x, which has no term for t in it whatsoever. Now we can note that the equation we have formed looks very much like what we call the quadratic equation in algebra, where the delta t squared corresponds to x squared and the delta t corresponds to x, and you'll note that c has no delta t term, neither does delta x. When we do this, we know that we can find the roots of this quadratic equation through a simple formula, tried and true, that many of us have used many times, where x equals negative b plus or minus b squared minus 4ac all over 2a. In other words, we'll have two answers, one where we take the negative b and add the square root of b squared minus 4ac, another one where we take negative b and subtract the square root of b squared minus 4ac. We'll note also that a, b, and c are simply the coefficients in front of the terms in our quadratic equation. Now, to solve this problem, all we need to do is realize that the a in the quadratic corresponds to 1/2 a in our physics equation. Now, I have added a subscript c because that's really the acceleration coefficient in our physics equation, and some students confuse the two a variables. A, b, and c in our quadratic are just generic, who cares what they are, they're something, type of variables to show the concept. But in our equation, the a stands for acceleration, and our coefficient in front of delta t squared is 1/2 of that acceleration. B in a quadratic corresponds to our initial velocity in our physics equation, and c corresponds to the negative of our displacement in our physics equation. Negative because, if you recall, if delta x is positive on the left side of our original equation, we bring it over to the other side using the add-subtract rule in algebra, we're taking the negative of that value. So whatever delta x is in our checklist, we use the negative of that value when we try to use that to solve the quadratic equation. Now, all we need to do is substitute our values from the physics equation for A, B, and C into the quadratic equation. Making that substitution, we see that x, in our case delta t, equals negative v sub I plus or minus v sub I squared minus 4 times 1/2 the acceleration times the negative displacement, all over 2 times 1/2 of the acceleration. So here we are, delta t in our physics equation equals negative v sub I plus or minus the square root of v sub I squared minus 4 times 1/2 the acceleration times the negative displacement, all over 2 times 1/2 the acceleration. This again is simply a calculation that we need to make, being careful, as we always are, to avoid digital errors with that large digit on the end of our hand pushing buttons on a little box. Okay, let's look at some unique issues though that we will have with this particular equation. Because quadratics are what we call a second order equation involving an exponent of 2, we will always have 2 answers to every problem. And mathematically, we will always have 2 answers to every problem. Now, what is key is looking at this term, b squared minus 4ac, which corresponds to our v sub I squared minus 4 times 1/2 the acceleration times the negative displacement, to see if in fact we're trying to take the square root of a positive or a negative number. Now, if our value for b squared minus 4ac, if that value is greater than or equal to 0, we will have 2 real roots to our equation. And in most cases, those 2 real roots will provide us with values for delta t, at least one of which will make sense physically for our problem. For example, if you were to have 2 roots to your equation and one was positive and one was negative, then obviously the positive number would be the one more appropriate to consider first, because in our frame of reference, time starts from 0 and moves forward. Also, if you have 2 positive roots, remember that the ball was going up and then down, meaning, of course, it could have a displacement on the way up and that same displacement on the way down for 2 different positive times. Finally, if b squared minus 4ac is less than 0, it would mean we were attempting to take the square root of a negative number. One of 2 things will have happened. First of all, recall that in mathematics, square root of a negative number is not such a big deal. There's a whole branch of mathematics that deals with this called complex variable analysis, where we have numbers that are a combination of real numbers and imaginary numbers. For those of you that go into engineering, such as mechanical engineering, you'll study these in great detail when you deal with a little problem called heat transfer. But obviously that's beyond the scope of this course. For our purposes, if we're trying to take the square root of a negative number, we'll get complex numbers with imaginary components for our roots, and that means one of 2 things. One, we either made an error when we plugged in some of our values, or maybe even when we identified our values for v sub I, delta x, or a, For example, maybe we had the wrong sign in front of our acceleration. Perhaps we had the wrong sign in front of our velocity. Perhaps we had the wrong sign in front of our displacement, or when we did our algebra, we started out with a negative displacement and forgot that we were taking a negative of that for our quadratic to get a positive. Any number of small little errors could creep in and make this happen. The other possibility is that we were given parameters for the problem that made the problem physically impossible. In other words, we were given a delta x, an initial velocity, and acceleration that just couldn't happen physically in time and space the way the problem said it would. In that case, we have simply shown that that outcome was physically impossible. Okay, you should have enough information now so that when you see the equation or relationship that relates delta x displacement, initial velocity, time, and acceleration, that you should be able to solve for any of the components if you know the other three.